Okay, we're continuing on to experiment 8. It's asking to arrange the following in order of acidity. If I'm asking you to figure out which one is a stronger acid or a weaker acid, make them act like an acid, right? So what that means is that each one of these is going to lose its hydrogen, right? We're going to lose a hydrogen, and we're going to leave behind the minus charge, right? Pardon me, I do have a little bit of a cold at the moment, so if my voice is a little bit nasally here, I apologize. I'm trying to deal with a little cold. But anyway, so we made all these act like an acid. Now remember that a strong acid, right, makes a weak base. So if we can find what's the weakest base, then we will know what's the strongest acid. And we could also think about the reverse, right? The stronger the base, the weaker the acid. So what makes a weak base? Remember, for a weak base, we want a delocalized negative charge, right? A delocalized negative charge. So what is the difference between fluoride, chloride, bromide, and iodide? Well, there is a change in electronegativity, right? There is a change in electronegativity. The fluoride, in theory, based off of electronegativity, right, should be able to handle that negative charge the best. But there's something else that changes, and it's radius, right? Your iodine is a much, 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 much larger ion than fluoride is. So that the negative in iodine is spread out over a larger radius as compared to the fluoride. So that's going to make the iodide a delocalized negative charge. It's a delocalized negative charge, right? So it's a weak base, and it comes from a strong acid. So in terms of acidity, the hydrogen iodide, the HI, is going to be the strongest. So the radius is what's going to affect our acidity here. The smaller the radius, the weaker the acid. So this is our weakest acid, third, and then fourth, okay? So 1 is weak, and 4 is our strongest, okay? We're going to approach this the same way here. We're going to make each one of these act like an acid by losing one of these protons. Let's see what happens. Here, right? Whoops, sorry, that should be a sulfur. We generate a negative charge on a carbon, right? We generate a negative charge on a carbon in all of these cases. So how can we stabilize that charge? They're all on a carbon, so we don't have to worry about electronegativity or radius. We can't really say too much about inductive effects. There might be something that's going on behind the scenes. But what else can we look at? Well, we're going to have to look at resonance in this case. We do not have any resonance here in the middle, right? No resonance here in the middle. No resonance means we have a very localized negative charge. A localized negative charge makes it a strong base, and strong bases make weak acids. So our weakest acid is going to be in the middle. Now let's draw some resonance. Whoops. So we push that here, we push that here, we push that here, we push that here. Let's draw our products. Sorry, I meant to do that in color. Our blue pi bond, right? Negative there. Oxygen, blue, lone pair. Okay. So now we've made a resonance structure that generates one pi bond and puts the negative onto a sulfur or puts the negative onto an oxygen. And again, we ask the question, what's the difference and what's the same? The same is that there is a negative charge. The difference is that one of them is on a sulfur and one is on an oxygen. So again, we have to pay attention to electronegativity and radius. Oxygen and sulfur, right, they are in the same family on the periodic table. Oxygen is more electronegative but has a smaller radius. Sulfur is less electronegative but has a larger radius. So sulfur is going to win in terms of the stability of that negative charge, which makes it a weaker base, right? Which makes it a stronger acid. So it's going to be the strongest acid here because it can stabilize that minus the best, and which puts oxygen right there. So go through, if I'm asking you to look at the acidity, make them act like an acid, and analyze what's going on with the negative charge afterwards. The weaker bases make stronger acids.